in our lesson today, we get to learn how to take square roots of negative numbers. And those are going to be our imaginary numbers. We'll also talk about how we work with simplifying things that have square roots in them. And we'll talk about the notation for complex numbers and exactly what all of that means. So to begin with, we start by defining the square root of -1 is the imaginary number I. And that's something that a famous mathematician years and years ago named Euler came up with. I know it looks like Euler, but it's pronounced Euler. Just that I means the square root of -1. That also means just definitions of what a square root is. I times itself is -1. I squared is -1. Those two things are equivalent. Square root -1 is I squared is -1. So anytime you are simplifying a square root of a negative number, first thing you're going to do is to rewrite it as the square root of the positive number and then times an I. That works because I could say -4 is 4 times -1, so √4, root -1. And with this definition that we have now, that square root of -1 is I, so I have √4 times I. Then we say, can we simplify the square root? And everybody, what's √4? So that we have 2I. So if we continue and do another one, first thing when we see one like this, square root of a negative, we are going to rewrite it as square root of the positive times an I. And then what will this one simplify to, Janae? What's √9? It would become 3 times I. Evelyn? Well, it's an imaginary number, so you can't really calculate what its value is because it's imaginary. It's just I is I. So square root of -12, what do I do first with this one, Abby? Not yet. First is √12 times I. Then, exactly what you were thinking, can we simplify √12? 12 is 4 times 3, so √12 is √4 √3 times the I. So Coleman, what's final simplified answer here? Hayden, what will I do with this last one? I'm asking you. So the square root of -13 is the same as this. Got to have the I in there. And then we can't simplify √13, which is what you were thinking of. And so we are finished with that one. Anybody with a question on that? Okay, what we're going to talk about next, we have to be careful when we start in with these negative square roots, and we are trying to do things like a square root of a negative times another square root. So we're used to, we can do things like what you see at the bottom of the screen, that if we have two square roots, we can put them together, or if we have one big thing like √12, we can split that apart, √4, √3. That works just fine as long as one or both are positive. But we run into trouble if they are both negative. Let's suppose I had something like the square root of -9 times the square root of -4. I am tempted, but it does not work if I say that's going to be the square root of -9 times -4, which is the square root of positive 36. Do I have any kind of a plus or minus sign in front of that square root? So that means positive. So that means positive 6, but 6 is not the correct answer to that problem. What you must do whenever you have square roots of negatives, first rewrite it as square root of the positive times I. Then go from there and you'll be fine. If you just remember, first deal with the I before you do anything else on the problem. Then I can group that as root 9 times root 4 times I times I. So I have 3 times 2, which is 6. What's I squared? How do we define I? What is I squared? What's it going to be, Mateo? Square root of negative 1 is I. What is I times I? What's the equivalent form to that I had you write down? Come on. Negative 1. I squared is negative 1. So I have 6 times negative 1. Negative 6 is the correct answer. Anybody with a question on that? Pull the I's out first, and you'll be fine when you're simplifying these. Evelyn? It's really kind of irrelevant on that. What I've just said is what you need out of that. Pull the I's out first, and then just do the calculations. Don't try to memorize these rules that the book has. So let's practice that a little bit here. These are both positive, so I don't have any I's to deal with. So everybody, that's the square root of. Okay, this one has one that's positive, one that's negative, so we should be okay here. But what we're going to do is to first pull the I out on this one and say we have root 3 times root 2 times I. And root 3, root 2 times I is what, Gabe? What's 3 times 2? So root 6 times I. And then we'll do one that's the tricky kind where they're both negative. So we pull the I's out, root 3 times I, root 2 times I. Regroup, put the square roots together, put the I's together. So we have root 6 times, what's I squared, everybody? So final answer is minus root 6 for that one. Does everybody feel okay with those? Okay, a little more work. We'll figure these powers of I out, and then we'll put some of them in your formula list. So I is just I. It is the square root of negative 1. But I doesn't simplify to anything beyond just I. It stays like that. However, all of the other powers of I become real numbers or I. So I squared is how much? So anytime you have a problem with an I squared, you need to change that I squared to a negative 1 to simplify it. I cubed is I squared times I, but I squared is negative 1, so I cubed is minus I. Because it's I times I, which is negative 1, times 1 more I, so it's minus I. I to the 4th, I could do this either I cubed times I or I squared times I squared. So that gives me I squared is negative 1 times another I squared is another negative 1 or a positive 1. So I have I minus 1 minus I positive 1 so far for my powers of I. Let's keep going. I to the 5th will be I to the 4th times I. But how much did I just say I to the 4th is? 1. So this is 1 times I or I. I to the 6th. That is I to the 4th times I squared. I to the fourth is 1. I squared is minus 1, so that's minus 1. I to the seventh is I to the fourth times I cubed. What's I to the fourth? 1, and I cubed is minus I, so 1 times minus I is minus I. I to the eighth is I to the fourth times I to the fourth. But I to the fourth is 1, so I have 1 times 1 is 1. So my next 4 powers were I minus 1 minus I plus 1. Yes, ma'am. But the most simplified form is I. Square root negative 1 is less simplified than I. We don't ever want to leave a negative inside a square root. Okay, I could keep going. I could say I to the ninth is I to the fourth times I to the fourth times I, or I to the eighth times I, and that would give me an I. Are you seeing a repeating pattern in here? So you need to memorize the first 4, I squared, I cubed, I to the fourth. So I minus 1 minus I plus 1. Everything else will repeat. And so to do those, you do like I did here. You factor out I to the fourth if you can, or I to the eighth, or I to the 12th, the biggest exponent power of 4 that you can, and see how many i's are left over. So write these 4 in your formula list as ones that you need to memorize. So we've been working with real numbers for years. We know we can graph those on the number line. We know how to graph integers, positives on the right, negatives on the left. We know how to put fractions in between those integers. We know how to put decimals in there. We can even put square roots in there if we know from a calculator what its decimal approximation is. That lets us know about where to put it on a number line. There is no place on the number line where imaginaries fit in. So imaginaries cannot be graphed on the number line. Imaginary numbers and complex numbers are very closely related. Imaginary numbers are completely imaginary. Complex have a real part and an imaginary part. The real part must come first. A is just some real number. B is another real number times I. And the imaginary must go last. It is not okay to say 3i minus 7. It's got to be minus 7 plus 3i. The I has to come last. So complex numbers are things that look like 3 minus 2i. Or maybe the square root of 7 plus 2/3 times I. Or maybe 1.6 minus 4i. So one real number plus or minus another real number times I. Interestingly enough, all real numbers are also complex. Because I could say that 3 is 3 plus 0i. For a real number, I simply am thinking of that as the real part plus 0 times I. And for that matter, I could also say that all imaginaries are complex if I think of those as 0 plus something times I. So square root of 3i is 0 plus the square root of 3i. When I write it as root 3i, it's imaginary. When I write it as 0 plus 3i, it's complex. So let's work on simplifying some of these complex numbers. If I just take 2 complex numbers, like 4 plus 6i, that's one complex number. And then I want to add -2 plus 3i, that's another complex number. Then it is just like combining like terms. I might as well be x as far as how I do the algebra. Got to start with the real first, have to end with I. So, Caden, what will my real part be if I just take the real numbers and put them together in that? So the 4 and the -2 would give me a +2. And then if I put my imaginaries together, just as if it were 6x and 3x, then what would I have for that one? Brad? So I would have the 2 plus 9i for my answer. And remember, not 9i plus 2. So that's easy enough, right? Okay, I could take 3 complex numbers. And here I'm adding the first 2 and then subtracting the last one. So exactly the same process. And Emily, what do I need to worry about with that last one when I'm subtracting that last one? I need to make sure I distribute the minus sign to everything. So I'm thinking of that as a -2 and a +5i. So we're going to take our reals, 4 plus 6 minus 2. What does that give us, Leah? 4 plus 6 minus 2. So 8 for our real part. And then for our imaginary part, what's -3i minus 4i going to be? -7i and then +5i, everybody? So -2i. And we have successfully added and simplified those complex numbers. One last kind of problem for today. Most of the time you will see this written as 2i squared minus 7i cubed instead of writing out those i's on those first 2 terms. This is where it's a little bit different from if it were x's. If we had x squares and x cubes in there, we'd have x squares and x cubes in our final answers. With i's, given what we just did with I squared, I cubed, and I to the 4th. If it's just an I, we keep it, but if it's a bigger exponent, we have to change it to just I or just a real number. So you guys are going to help me work our way through this. What did we say I squared is? So that the first term is 2 times -1. Then I have -7 times I cubed. What did we say I cubed is? It is -i. 2i is just fine. We don't go back to a square root of -1. I is the most simplified. The -4 is just fine. Oops, I left out my minus sign on this one when I recopied that one. Minus the root of -3. That's when we're going to do minus, change it to a square root of 3 with an I. Now we're going to clean it up a little bit and combine our like terms on this thing. So we have a -2 and a -4, and I think everything else has an I in it, right? Back, what do I get for -2, -4? I have -6 for my real part. Then I have, this one becomes a minus is a +7i. Plus 2i is how much, everybody? So +9i. And then I have that -√3i. The problem with this is I wrote I twice. And a complex number needs one real number plus one real number times I, not one real number plus something I plus something else I. But I can't just add the 9 and the -√3 in there. So what I do is I keep my real part, I factor out my I and put parentheses in. And then the parentheses are going to say, inside of the parentheses is one real number, even though I can't simplify it any more than this. It makes one real number times I. So I'll leave that as 9 minus 3 all times I. And then this last one, I want you guys to try on your own first, and then I'll catch up with you. So you guys copy this one down, change those powers of I to either real numbers or just to an I, and then put together the reals and the imaginaries. So help me catch up to you guys now. So Kira, what is I cubed? And Ada, what is I squared? And then the next one's okay, it's just an I. And the 7's okay. And then I to the 5th, I'm going to factor out the biggest power of 4 that I can for that exponent. So that's going to be I to the 4th times an I. And everybody, what's I to the 4th? So that's just a 1 right there. So what do I have? Minus 3I, minus 5, plus 5I, plus 7, plus 2I. Does that look right to everybody? Is that what you guys had? So Griff, what do I get when I combine my like terms here? 7 minus 3. What do you guys think? 2 plus 4I. Give me a thumbs up or thumbs down. Anybody with questions on that? All right, good job with that material today.